Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So, for today's lecture, let's continue from the previous lecture, which is still under Descriptive Statistics. This is part 2. On last lecture, we already looked into a measure of central tendency, measure of dispersion, measure of skewness, and measure of position, as well as a coefficient of variation. So we already looked into some statistical measures that are very important and is fundamental to know all these measure: mean, mode, median, standard deviation, variance, quarter 1, quarter 2, quarter 3, and coefficient of variation. Right. So now for this lecture, we are looking into a graphical presentation for our descriptive statistics. Right. Let's go back to the previous slide. Right. In this slide, right. In this slide, we are focusing on qualitative. For organizing and graphing data, there are two types of data, which is qualitative data and quantitative data. For quantitative data, right, means that when we have a numerical data, and this is numerical data, right, we can do a stem and leaf plot, box plot, frequency distribution, and histogram. Right, for qualitative data, we can graph or organizing data using frequency distribution, pie chart, and bar chart. This is the main focus on our syllabus, right? But basically, there are more type of graphing available for qualitative and quantitative data, but we are only focused on stem and leaf, box and whisker plot or box plot, frequency distribution, and histogram for quantitative data, and pie chart, bar chart, and frequency distribution for qualitative data. Right. So let's begin with the quantitative data. We look into a box and whisker plot, right? Box and whisker plot, or what some book call it as a box plot diagram. Box plot diagram. So box plot provide a useful graphical presentation of data using minimum, maximum, first quartile, third quartile, and the median value. Basically, in designing or graphing a box plot, we need a 5 summary, a numerical summary known as minimum value, maximum value, first quartile, third quartile, and median value. So as you can see, this is the graphical presentation for a box and whisker plot. So, or what box plot, right? So the minimum value will be on the left side, and the maximum value will be on the right hand side. So the first box, right, will represent the quartile 1. The last box will represent quartile number 3, and the middle will be quartile number 2, or what we call as median lah. So if what the box plot tell us, it will tell us the skewness of the distribution, the shape of distribution. Either is normally distributed or symmetrical distribution, or negatively distributed or positively distributed. So let's look at the first one. If the box plot, the median value is in the middle of the box and have equal width or equal length on the right hand side and the left hand side. So the length on the right hand side are equal to the length on the right hand side. So this is normally distributed data, right? So when the whisker and the rectangular box is longer on the left hand side, right? So the left hand side is a bit longer, and we can see the whisker also longer on the left hand side. So this is what we call as a negatively skewed, or skewed to the left distribution. Right. In other hand, so when the whisker and the rectangular box is longer on the right hand side, right? So this is longer on the right hand side, and the whisker also longer. So this is what we call as positively skewed, or skewed to the right distribution. So basically, the box and whisker plot will tell us whether the data is normally distributed or skewed distribution, right? Okay. Okay. Let's look at SPSS output for box and whisker plot, or box plot. So in SPSS, normally it will provide outlier. It will show if the data have an outlier, it will show an outlier in the box plot. So this is the for this one. This is the basic information that we need to know for a box plot from a 5-minute some numerical summary. So we have minimum, quarter 1, median, quarter 3, and maximum. And we need to remember, again, I just want to emphasize, when the middle box and whisker are equal length, so then this is a normal distribution. When the whisker and rectangular box is longer on the left hand side, so then it is a negatively skewed. When the whisker and rectangular box is longer on the right hand side, then it is a positively skewed. Now let's look at SPSS output. So what is an outlier? So first, outlier is an extreme high or extremely low data value when compared to the rest of the data value. So this is an example when we can see the rest of the data are in this trend, but suddenly we have some observation are out of the range, right? This is what we call as outlier lah. So this is one of the example. We can see all the data in one trend line, but this is a possible outlier lah, because it's a skewed or out of the range. So in a box and whisker plot SPSS output, it will present in term of in like this lah. So this is the minimum, this is the maximum value, this is a minimum value, right? And this is a quarter 1, quarter 3, and median, right? So to read the box plot in SPSS, we need to rotate to 90 degree to the right, right? So we can see the shape of distribution, either skewed to the left, or skewed to the right, or normally distributed, right? So this is one of the example of SPSS output. Now let's look at the SPSS program. Okay, so this is the SPSS program at IBM SPSS Statistics Data Editor. So I already load the data in the SPSS. So I just want to show you, I just want to demonstrate how to plot a box and whisker plot for numerical data. So we need to make sure this data is a numerical. Let's look at the measures for this variable. This is a scale variable, means that this is a numerical variable. So you need to remember, for a box plot, we need to have a numerical variable or numerical data only to construct a box and whisker plot. So now let's say I want to create a box and whisker plot for this variable. So I just need to go to graph and click on legacy dialog and find box plot, right? Again, graph, legacy dialog, and find box plot. So let's say this dialog box will appear. So I will choose simple and click on summarize of separate variable, because I want it to measure for only this variable, not by group, right? Later on I will show how to measure by group. So then I click on summarize of separate variable and click on define, and then this dialog box will appear, right? It will show on the left hand side, it will show all the variables available in this data set, and this is the box represent the first box. Second is labeled by cases by, and this is panel box plot lah. We don't want to touch any of the others than first box lah. So now let's choose the first variable, which is the first variable that I want to create a box plot, and input it into box represent, and then I need to click OK. So the output will be appear on the output window. So this is the box plot. SPSS will give us two result here. The first result is case processing summary, and the second one is the box plot, right? So the case processing summary will show us how many observations are available in the data set, and how many missing value. For this case, there are no missing value. And then the box plot. So let's see, I copy this one, right? Copy, and I paste in this, right? So next I want to, so this is the box plot. I want to rotate, right? Alright, I think I cannot rotate here. Maybe I should go to here and double click and click rotation lah. So transpose and then close. This is the example. Let me copy and paste here. Right. So this is the box plot that we want. So if you can see here, this is the minimum value. Right. Let me draw. Right, this is the minimum value, and this is our quarter 1, and this is quarter number 2, or what we call as median, and this is quarter number 3, and this is the maximum value. So if you can see here, the length on the rectangular and the whisker are longer on the right hand side. So we can say that this data have a positively skewed data. Let's look at another example. Let's go to graph, legacy dialogues, box plot, and simple summarize separate variable define. Let's try another variable, which is this one, and click OK. So now you can see here, right? Let's say I double click to enable our data editor, right? And click on transpose and OK. Copy this one and paste on our OneNote, right? So again, this is the same structure for box plot. We have minimum value. This is quarter 1, quarter 2, quarter 3, and this is maximum, and this is the outlier in the data, outliers. So again, to interpret the data, the graph, we can see we should look into the rectangular on the right hand side and whisker on the right hand side, also longer on the right hand side. So this is a positively skewed. So we know that the data have a positive skewed distribution, right? So now let's look at example number 4. In example number 4, construct a box and whisker plot for the data below. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equal to 9. So to construct a box and whisker, we need to have 5 elements: minimum value, quarter 1, quarter 2, quarter 3, and maximum value. So the minimum value, before we proceed further, let's rearrange the data in ascending order, right? So the lowest data is 8 and followed by 12, 18, and then 20, then 30, 34, and then we have 40, 42, and 58. So altogether are 9 observation. So this is position 1, 2, 3, 4, 5, 6, 7, 8, 9. So the minimum value will be 8. The maximum value will be 58. Now we need to find quarter number 1. To find quarter number 1, we need to find the location of quarter number 1, n plus 1 divided by 4. So this one should be equal to 10 over 4. So 10 over 4 should be 2.5. Right? 2.5. So quarter number 1 will be somewhere between 12 and 18. So 2.5, 12 plus 18 divided by 2. So it should be equal to 15. So quarter number 1 is 15. Quarter number 2 will be n, the location is n plus 1 divided by 2. 10 over 2 equal to 5. So quarter number 2 will be 30, right? 30. And quarter number 3, the location will be 3 multiplied with 10 divided by 4, which is 30 divided by 4 is 7.5. 7.5 somewhere between 40 and 42. So 40 plus 42 divided by 2 should be equal to 41. Now, let's begin to construct a box and whisker plot. So the minimum value will be 8 and the maximum value will be 58. Quarter number 1 somewhere here is, this is the minimum value. Let's say this is 15, right? And quarter number 2 will be somewhere here, which is 41, and quarter maximum value is 58. So the quarter number 2 will be a bit slight on the, a bit longer on the right hand side lah, right? So 30 minus 15 should be 15. 41 minus 30 should be 11. So on the right hand side should be longer compared to, on the left hand side should be longer compared to the right hand side. So if you measure it properly, we will see there is a skewed to the left distribution. So this is a skewed to the left distribution. Let's try to do in using SPSS. So try to create a new file. We just click on File, New, Data. Right? It will give us a new window, right? For us to input the data lah, right? So let's try. Before we key in the data into SPSS, we need to create a variable. Let's say this is data, right? And we want to make sure this is a scale data and no decimal point, right? I would like to have it as center align. For now, I want to key in the data 12, 18, 20, 34, 8, 42, 30, 58, and 40. So we have 9 observation. So click on Graph, Legacy Dialog, Boxplot. Simple, summarize separate variable, define. And input the data into box represent and click OK lah. So this is the data. And we try to transpose it to become on like this, and this is going to be our oops, let me clear this one first and put here. So this is the result from SPSS. If as mentioned, on the left hand side is bit longer compared to the right hand side, right? So this is skewed to the left distribution, right? Even though the whisker is a bit shorter compared to the right hand side, but the main concern is on the rectangular box, right? So this is a skewed to the left distribution. Now let's move to the next plot under quantitative measures, right? This is a stem and leaf plot, right? So stem and leaf plot is widely used in exploratory data analysis, right? When we want to see the shape of distribution, whether the distribution is normally distributed or not normally distributed. So normally stem and leaf is used when the data set is very small, when n is less than 30. When we have a number of observation is less than 30, then we can use stem and leaf plot. So the plot separate the data entries into leading digits and trailing digits. So leading digit should be on stem and trailing digit will be on leaf. So it allows us to show the range of data value and shape of data value and rotate the plot by anti-clockwise to see the shape of distribution lah. Later I will show you. First, we need to split the value into two sets of digits. The first set of digit is stem and the second set is leaf. So let's look at example number 5. So we have 3.4, 4.5 and so on. So we can see there are two digits here. So we can easily differentiate lah. Let's say 3 as a stem and trailing digit should be 4. So we'll present 3.4. Right? So now let's try to construct a stem and leaf. So first we need to construct stem and leaf. So this is stem, this is leaf, right? So let's say we start from the lowest value. That's why we need to rearrange data from the lowest value to the largest value first before we start constructing the data lah. So let's say 2.3, 2.4, 2.7, right? This is our first digit for 2, and 3.4, 3.4, right? And then we have 3.6, and then we have 3.8, right? And then we have 4.1, 4.5, 4.7, right? This one already cancel, and then we have 5.1 and 5.9, right? So let's try to put the trailing the leading digit first lah. We have 2, right? The first one 2, the second one is 3, 4 and 5, right? Then we try to input the leading trailing digit, which is 0.3 kan. So we put 3, 4, 7 for number 2, right? And then for 3 we put 4 and 4, right? And 6, 8, right? And 4, 1, 5, 7. Number 5 is 1 and 9. So this is stem and leaf, right? So if you rotate into anti-clockwise, right? Let's see, we copy and paste here. Let's see, I paste it here, and I want it to rotate this one. How to rotate this one? Then I already rotate the stem and leaf, right? So now, let's see, I put it here so we can easily see. So now we can see here there is a skewed to the right distribution, if you can see, right? So the numbers of mode are at the second row, and it shows a decreasing trend to the right. Right, so this is a skewed to the right distribution. Right. Okay, so okay, let's try to do with SPSS. Right, let's open SPSS, new file, new data. Right, so I'm trying to input the data that from example number 5. So before we key in the data, we need to create a variable. Right, so let's say this one we call as data 1, data 2, and make sure the measures is scale and decimal is 1 decimal point because 3.4, and I want it to be on the center. Right, so now 3.4, right, 3.4, 4.5, 2.3, 2.7, 3.8, 5.9, 3.4, 4.7, 2.4, 4.1, 3.6, and 5.1. Right, once you already key in the data, so we need to go to analyze, and go to Descriptive Statistics and click on Explore. Right, analyze, Descriptive Statistics, and click on Explore. So we input, if you can see on the dialog box, on Explore dialog box, on the left hand side, this is all the data variable available in your data set. This is the independent list, factor list, and label cases by. The dependent list should be only numerical. For factor list should be categorical variable. So we input data 2 in dependent list, and we click both. Right, on plot button, we make sure the stem and leaf is selected. Right, and I think that's all. Click continue and click OK. So Boxplot, SPSS will give us the the result, which is the first one is case processing summary. Will show you how many data observation available with missing value, and this is some descriptive statistics. It show us the mean, standard deviation, variance, minimum and maximum, range, interquarter range, and so on lah. So what we want to see is the stem and leaf plot. So same as our work drawing just now, SPSS are doing the same process as our plot, right? So you can see that this one is having a slightly skewed to the right distribution, right? Okay, that is for SPSS lah. So now let's look at example number 6. The following chart represent the age years of managers at manufacturing company in Malaysia. So this is the stem and leaf graph display. So if you can see here, it shows that the distribution is skewed to the right distribution, right? If you rotate this one, it will show the distribution is skewed to the right distribution lah. So how many managers involved in these studies? Right, so we can count how many managers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we can count one by one. So there are 40 managers, right? So how we know? We need to count on the trailer side lah, on the leaf side, right? So if mode is 37 years old, so what is the value of Q? Right, hence calculate the mean age of the manager and interpret both value. So since it says that the mode is 37, we will assume that this is also 37, right? So Q will be 37. 7. And we need to calculate the mean age of the manager. So we can calculate the mean age of the manager. So to calculate mean age of the manager, we can use calculator, right, to input all the data, right. Let me clear this line because I cannot see the line. So let's input the data. So to input the data, we need to click on mode and find stat number 3 and find 1 by minus variance, right. So we just try to input 30, 30, 31, 31, 31, 2, 32, 32, 4 times, 34, 34, 34, and 35, 35, 35, 36, 37, 7. So all together are 40. We can recheck back whether our data is correctly input into the calculator. 30 we have 2 times, 31 we have 3 times, 32 we have 4 times, 1, 2, 3, 4, and 34 we have 3 times, 35 we have 3 times, 36 1 time, 37 is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This 38 is 1, 39, 40, 4 times, 1, 2, 3, 4, right. 41 we have 2, 43 we have 3, we have 2, 45 we have 2, 47 we have 3, 50 we have 2, 51 only 1, and 55 all together are 40 lah. So remember the mean, the formula for mean is x bar is equal to summation of x divided by n. So we need to find the summation of n, summation of x should be shift 1, click number 3 for sum, and click 2, right. So it should be 15551 divided by 40, right. So to get the value of mean, you can click shift 1 and click on 4 and find mean number 2. It should be 38.37, 38.775. It should be, since we agree that we want 2 decimal point, it should be 38.78 years old, right. So then they ask us to find median age of the managers, right. So in stem and leaf plot, the data is already in arranged in ascending order. It's already arranged in ascending order. This is position number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This is 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, and this is 40. So location of median is equal to n plus 1 divided by 2. So 41 divided by 2 should be equal to 20.5. Is it? 41 divided by 2. 20.5. So 20.5 is somewhere between 37 and 37. So the median will be equal to 37. 37, right? So state the youngest and oldest age of the manager. So the youngest means that the minimum value The oldest means the maximum value. So the youngest will be 30 years old and the maximum is 55 years old. So minimum value is 55, this is 30 years old, right? 30 years old and this is 55 years old. Very simple to obtain the value. And state the skewness of the above distribution and explain what it means. So the skewness of the distribution, as we can as we already said state just now, right, it is a skew to the right distribution, right? So this is a skewed to the right distribution, right? So what does it mean? It means that the number of younger managers are more compared to the older manager, the elder manager lah. Right. So let's move to the next plot, which is histogram. Histogram is a bar chart, is a type of bar graph, right, of a raw data that creates a picture of the data distribution. The objective again is the same. We want to see the shape of the data distribution, right, whether it's skewed to the right, skewed to the left, or normally distributed. So bars represent the frequency of occurrence by class of data, right? So histograms show basic information about the data set, whether central, location, width, spread, and shape of distribution. So this is an example of histogram shown in SPSS result. So if you can see the first one, this is the first one, this is second, and this is third. Alright, the first one we have a skew to the right distribution, and then this is a skew to the left distribution, and this is normal distributed lah. Right, we can see from the shape of the data, the graph, right? So the next, this is just an introduction lah. If you want to create a histogram from the SPSS, let's open this data set, right? We just need to go to graph, legacy dialogs, and click on histogram, right? Again, graph, legacy dialog, and click on histogram. So there are the dialog box will appear for histogram. On the left hand side is all the variables available in your data set. This is the numerical variable should be to display the histogram, and there are options to display normal curve for our easiness to identify whether the graph is normally distributed or not normally distributed. Let's see the first variable, right, and then we click on display normal curve and click OK. So now we can see from the output, oops, where is it? So this is the output of the data. So if you can see, there are no clear distribution for this data, but you can see that the most of the data is on the left hand side lah. So this is going to be slightly skewed to the right distribution lah, if you can interpret it very clearly, because the most of the data are on the right and left hand side, and others are distributed evenly on right hand side, right? So this is how we create a histogram for this data. Let's see another data. Let's look at this data, the data 1 that we already created before. So since we already run the histogram before, we can simply click this icon to recall the previous step. So we can click on histogram and put the data into variable and display normal curve. So if you can see here, for our new data, so it shows that it's normally distributed, but this data is not very small data, not really clear distribution shown, right? So that's how we create a histogram from SPSS, right? Okay, let's continue on the next topic, which is frequency distribution. So this frequency distribution is a table, just a table, consists of row and column. Consists of row and column with the purpose to summarize the data into different classes and their frequencies. So in the frequency distribution, just a frequency table, it summarizes how many observation in each category, right? So the class is a category into which qualitative data can be classified, such as gender, male or female, ethnicity, Malay, Chinese, Indian. And then in class frequency distribution, it consists a class frequency. So class frequency is the number of observation that fall in particular class. So let's see the frequency distribution produced by SPSS output. So this is the frequency table. Right? So it consists of class male and female, and then this is the class frequency, which is 13 male equal to 13. There are 13 male in the data set and the X female, right? So let's look at how we're going to produce a frequency table using SPSS. So let's try to open a new data. So file, open data, right? So in SPSS there are freely available data come with the SPSS. So where to get it? So you need to go to program file, right? Program files, and find IBM SPSS Statistics. It actually follow your version lah. If your current version is 28, so you need to open folder 28. Mine is 26, right? So then you need to go to sample, right? And then choose English, right? So in this folder there are a lot of ready data set available in the SPSS. So let's look at demo.sav, right? Demo.sav, and click open, right? So this is the file or dataset for demo.sav. So let's see the car category. So this is this is a primary vehicle price category. So in this category, it consists of economy, standard, and luxury. So let's look at the data. So to get a frequency table, we just need to go to analyze descriptive statistics and click on frequencies, right? Again, analyze descriptive statistics and click on frequencies. So in this frequency dialog box, it consists of two boxes. On the left hand side consists of all the variable in your data set, and on the right hand side is your is a selected variable that you want to make analysis, right? So let's select primary vehicle price category into the variable box, and then click on statistic button, right? We just need a frequency, so then we don't need to click anything, right? So click cancel and make sure you click on display frequency table and click OK. So in this result, it will show you two main table, which is statistics and primary vehicle. Let me copy this one into our OneNote, right? So let me paste here, right? So this is a frequency table produced by SPSS output lah. So in this frequency table, we can see the class. There are three classes which is economy, standard, and luxury. And then on the right hand side, we have a frequency, percent, valid percent, and cumulative percent, right? So frequency is the class frequency, means that there are 1841 observation for economy, 2275 observation for standard, and the total observation available are 6400. And this is the percentage. This percentage and this percentage usually are same when you don't have any missing value. If you have a missing value, you can see on the notes that you have. If you have a missing value, it will state a missing system. Means that there is a 2 observation missing. So the percent here is not really a valid percent. Means that it will compute for a missing value as well. So you need to rely on the valid percent to know which the valid percent lah, without the missing value. Let's try to demonstrate with the missing value. Let's say I delete one value, let's say 2 value for car category. So then I try to do a same process, analyze descriptive statistics and frequencies, and I input this variable and click OK. Now since I already delete two observation, so let me copy this one and paste here, right? So since I already deleted 2 observation, now in the frequency table it will identify 2 rows have a missing value, but still the total observation will be 6400. So the percentage here will also include the missing value lah. So you need to rely on the valid percentage to know the percentage of each category lah, right? Okay, so next let's look at the question, right? So this is the example of frequency distribution produced by SPSS. So the first table is given by statistics. So it shows that there are 30 valid observation and 2 missing value. The mode is 2, minimum is 1, and maximum is 2. So this is the frequency table, right? So to know how many females are in the in this frequency table, which is X, so we need to subtract. So 30 minus 13. So this one should be equal to 30 minus 13 should be equal to 17, right? So then percent is not a valid percent. It will consider the value of missing value as well. So what we need to do is, let's say we start with Y, right? So if you want to find Y, right, so 13 divided by 32 multiply with 100%. So this one should be equal to 13 divided by 32 multiply with 100% should be equal to 40.63, right? 625. So I round out to 63. So it should be equal to 6, right? And then the total Z value here, you don't need to do a multiplication. So we just need to subtract 100 minus 93.8 minus 53.1 minus 40.6. Oh, sorry. It will not work like that lah. Alright. So the missing value should be calculated as it is. Should be 2 divided by 32 multiply with 100%. So it should be 2 divided by 32 multiplied with 100%. It should be equal to 6.25%, right? So this is the value, missing value percentage. So now the question here is how many respondents were involved in this study. So there are 32 respondents involved in this study. So how many female respondent value of X should be equal to, we already calculate X, right? Calculate X. X is equal to 30 minus 13 should be equal to 17. Right, the value of Y is 40.6 and shows that value of Z is 6.3. So we already shown that 6.25. So if you round up, should be equal to 6.3. So 2 divided by 32 multiplied with 100% should be equal to 6.3 if you round up to one decimal point. So what is mean by missing in the table above? Missing means that the respondent does not fill in the gender, right? So when you ask a question about gender, that respondent is not respond to that question. So based on the statistic box above, what is mode referring to? Mode is the most frequent value is 2 lah. 2 means that let's say when we code the value male equal to 1, female equal to 2, so means that mode equal to 2 is most of the respondent is female, right? It's female because when we code a value, 1 is for male, 2 is for female, right? So this is the how we answer the question lah. Right, so enough with the frequency distribution. Later on we will discuss more detail on the statistic IBM SPSS output for frequency distribution. Now let's look in brief what is a bar chart. So bar chart is a chart that use either horizontal or vertical bar to show comparison among categories. We want to know which category is high, which category is low, right? By using a bar chart lah. So bar chart is mainly designed for a qualitative data lah, for a categorical data. So if you can see, this is the example of vertical bar chart. For horizontal bar chart, it should be on like this lah, just flip 90 degrees of the vertical bar chart lah. So it shows that how many frequency or how many respondent in the data set, right? So let's say American Indian should be equal to 5. So the lowest ethnicity in this data set is American Indian, right? The highest ethnicity is Caucasian lah, right? So some bar chart represent present bar clustered in group of more than one category. So this is what we call as a cluster bar chart. So if you have more than one group in one category, let's say this is very happy, so we want to know in very happy what is the proportion, what is the frequency for male and female. So this is for male and this is for female. Normally for cluster bar chart there is a legend to show the category of each class, right? So then we have another type of bar chart which is a stack bar chart. This is number 3. So stack bar chart is still same as a component bar chart or multiple bar chart, but instead of showing side by side a bar in one category, it will stack the category into one bar. right? If you can see for clerical work, right? Uh, so there is a male and female, right? So the proportion normally a stack bar chart will present in a frequency or percentage, right? So let's look at the next chart for categorical variable. Alright, for pie chart is actually a circular graph that show relative contribution that different categories contribute to all overall total. Means that in pie chart utilize only categorical variable for a single categorical variable to show the percentage of each category, right? So the pie chart can present what was so let look at this one. What data can presented using pie chart? So pie chart are a visual way of displaying data that might otherwise be given in a small table. So pie charts are useful for displaying data that are classified into nominal or ordinal categories. So it can be either nominal or ordinal categories, right? Basically, pie chart is for qualitative data lah. So pie chart are generally used to show percentage or proportional data, and usually the percentage represent by each category is provided next to the corresponding slice of pie. So let's look at the pie chart. This is example of pie chart lah. So this is a pie chart, right? So it's a circular chart, right? Consists of each categories in the categorical variable. So each category will have a percentage value in each slice, right? Will present the percentage of the categories, right? So this is just a example or introduction to a pie chart. So this is one of the example pie chart produced by SPSS Output lah. So now let's look at the SPSS output for all descriptive statistic and graph, right? So we remember in part 1 and this part we already discussed on descriptive statistic, basically on measure of central tendency such as mean, mode and median, measure of dispersion, variance and standard deviation, and then we already discussed about skewness, right? The normally distributed, skewed to the right, skewed to the left, or skewed to the right or skewed to the left. And we also discussed on the measure of position, which is quartile 1, quartile 2, and quartile 3, and the coefficient of variation. So this is one of the um, example of the SPSS output. So in this example, the data were collected on 200 high school students and a score of various tests, right, including science, mathematics, reading, and social studies, right? So now the variable female is a dichotomous variable coded as 1, and male is coded as 1, and female female is coded as 1 and male is coded as 0. So we have gender. So we have female and male. So male is coded as 0, female is coded as 1. So first output, which is a descriptive statistics. So in this descriptive statistics, it only produce for a numerical data, which is a quantitative data. So writing score, right? We have two rows here. So rows number 1 and rows number 2. If you can see, let me make it bigger. So rows number 1 is a writing score, which is our variable of interest, and row number 2 is valid n, which is it will tell us how many observation there are in this data set, that have no missing value. If there is a missing value, there will be another row will tell us how many missing value. So n, the first value here is n. N is the number of non-missing value. It will tell us how many observations are included in the analysis. So n is capital N is the number of valid observation for the variable, which is the total number of observation is sum of n and the number of missing value. Right. The next column, which is minimum. Minimum is the minimum value lah, right, which is the smallest value in the variable. The maximum value is the largest value in the variable. The column number 3. Then we have column number 4, which is mean. Mean, they will give us a statistic and the standard error. Right, so statistic for mean is 52.77. So means that the mean of writing score is 52.77. And then beside mean, they give us a standard error. Standard error means that standard error means that the standard deviation divided by square root of n. But we will ignore the standard error in mean, right? Because we are not really interested in the standard error right now. So standard error basically 9.47 divided by square root of n, which is 200. So you will get 0.67. And column number 5, right? It will show us the standard deviation. So standard deviation is the square root of the variance, right? So it measures the spread of the data observation, right? The larger standard deviation, the more spread the observation. This one is we already discussed earlier. And then this is the variance. The next column is variance. The variance is power 2 of 9.47, right? So 9.47 power of 2, we will get 89.84. So then we will have a skewness column. So the skewness column will tell us whether the data is normally distributed or not normally distributed. So since in this table, in this result, we can see that we have negative 0.482, which is a negative, so it means that the distribution is skewed to the left distribution. And then we have the value of kurtosis. Kurtosis means that how big the distribution, right? So this will give us the value of the bigness of the distribution, right? Let's look at the definition of kurtosis. Kurtosis is the measure of heaviness of the tail of the distribution. A normal distribution has a kurtosis 0. Extreme non-normal distribution may have high positive or negative kurtosis, right? So this is the definition of kurtosis lah. So this is a descriptive statistics. Right. So I would like to show you how to get this output in SPSS. Let's open demo dataset. Previously we already opened. So remember, for a descriptive statistics, it's only meant for a continuous variable. So continuous variable means that it should be a numerical variable. Let's choose one. Let's say we choose income, right? Income variable. This is a household income in thousand, right? This is a numerical data. Let's say the measure is scale, right? So to get the same result as this one, right? This is totally different variable, right? So we are using demo dataset. So to get that result, descriptive statistic, we need to go for an analyze tab, right? And then we need to find descriptive statistics and descriptive, right? Analyze descriptive statistics and choose descriptive, right? And then we need to input in this descriptive statistics, descriptive what we call as a dialog box, or there are two box, right? On the left hand side is all the variable in the dataset. On the right hand side is the variable that we wish to analyze, right? So we're going to select household income in thousand. We put it into variables, and then there are three button on the right hand side. So we choose option button. We click on option button, and for option button it will come out the pop up a window, right, to choose what kind of descriptive measure that we want, right? So let's see, by default, SPSS will take mean, standard deviation, minimum and maximum value. This is by default. So we need to add another descriptive measure such as variance, standard error of the mean, courtesies, skewness, and so on lah. If you want to get range, you could also click on range. And then we display order by variable list. Since we only have one variable to show, right, it doesn't matter this one. So then we need to click on continue button, right, and then click OK. So SPSS will give us the result. So this is the result, same as this result. So if you notice that the layout of the table is quite different, because in this node the layout is based on the previous version, right? But we can also modify our layout to be on the older version, right, by doing some modification lah. But doesn't matter, it still give us the same result. So it will give us the total observation, minimum, maximum, mean value of the household income, and the standard error of the mean, standard deviation, variance, skewness, and courtesies, right? So that's how we create this output using SPSS, right? Let's move to the next topic, which is descriptive. Again, this is still same result, but in different order, right? So it will give us the case processing, summary, and descriptive. So this descriptive are same as this kind of output, but this output we are getting this result by using others function lah. So in SPSS, you need to remember there are several ways to get the same result. If you want to get mean, median, and variance, right? So we can get the result in several ways. So let's see how to get this kind of result. And in SPSS, right, we can go to Analyze, Descriptive Statistics, and click on Explore. Right, again, Analyze, Descriptive Statistics, and click on Explore. Right, and then I think this one I already shown to you earlier. Right, let's say we want to measure household income in thousand. We just click this variable into dependent list, right? And then display, there are both statistic and plot. We just want SPSS to show us statistics, and we click on statistics and make sure 95% confident interval. This is by default, we don't need to check, also can, right? And then we click OK. So SPSS will give us these two tables. So these two tables are same as this one, right? So the first table is a case processing summary. It will tell us the valid observation, missing observation, and the total observation, right? The valid observation is referred to the non-missing cases, right? The missing column refers to the missing cases, and the total number of observation refers to total number of cases, which is including non-missing and missing value, right? So then the second table, it will give us the result for descriptive statistics. So in this table, there are fixed statistical measures, right? Such as mean, confidence interval, upper and lower, median, variance, standard deviation, minimum, maximum, range, interquarter range, skewness, and kurtosis. Right, three mean also included. Right, so by using this method, we no need to click many steps, such as in this result. Right, so in this result is very long. It's a white table, so it's hard to read. Right, for each as numerical summary is very hard to read lah. So for this table, it's very easy to read, right? We can know the value of median 54, variance 89.89, and so on lah, right? So next table is percentile, right? In percentile, they will give us the information of quartile 1, quartile 2, and quartile 3, right? So but back to this table, it does not give us the value of quartile, but they give us interquartile range. So interquartile range means that quartile number 3 minus quartile number 1. So it still provide the information of quartile lah, right? So now percentile result, it gives us the value of percentile. Percentile means that it's different from quartile. Percentile divide the data into 100 parts. Instead of quartile divide the data into 4 equal parts. But for percentile, it divide the data into 100 parts. That's why we have 5, 10, 25, 50, 75 until 99. So 5 means this is going to be lowest value, and this is going to be the largest value. Right, 25%, this is a quarter number 1, this is quarter number 2 or median, and this is quarter number 3, right? So to get this table from SPSS is very easy. It's just the same step as previous step. We just need to go to Analyze, Descriptive Statistics, and click on Explore. Right? It's the same step. So previously we already include household income into dependent list and click on Statistics. So now we need to click on Statistic button, right? So we need at the first previously we only make it as default, right? We don't really make any changes, right? So we just click on descriptive. So now to get the value of percentiles, we need to click on percentile option and click continue, right? So SPSS will provide 3 tables basically. Table number 3 is the percentile, right? So this is the value of quarter 1, quarter 2, quarter 3, right? Okay. Right. To get histogram from the SPSS is very simple. I think I already shown it before previously, right? Let's say, but you need to remember before I proceed, histogram is only meant for quantitative variable, right? Quantitative variable, and it is to show the shape of distribution. Let's see the demo dataset. We want to get the histogram for income. Previously, I was showing you how to get the histogram from graph, legacy dialogues, and click on histogram. And then we input household income into variable and click on display normal curve and then click OK. Right? So it will give us the value, the histogram plot. Right? So there is another way to get histogram from the SPSS. As I said, there are several ways to get same output from the SPSS. Right, so we can go to Analyze, Descriptive Statistics, and click on Explore. right? Instead of click on display only statistics, we can display both or only plot, right? So let's say we click on plots, and then we choose plot button, and then for by default it will automatically select box plot, stem and leaf, and histogram. Histogram does not this is not selected lah. So we need to check for histogram to get these three graph, right? Then we can click continue and click OK. So SPSS will provide us the value of the graph for histogram, stem and leaf, and box plot. If you can see, box plot contain a lot of outlier, right? And if you can see, the histogram will show skewed to the right distribution, right? So same as this one lah. So by using this method, the histogram is not showing the normal distribution curve. So we can double click, right, and then choose click on the graph and click on show distribution curve, right? It will automatically show the distribution curve, and then we click cancel, and we see the distribution curve on the histogram, and then it will show us the stem and leaf plot and box plot, right? So I can skip this one and this one, right? I think that's all for chapter number 2, right? So there is a tutorial on your lecture notes. We have several questions until question number 10. We have 10 questions, right? So I require you to do all the questions, but before I let you go, let's try to look one of the question. Let's try to look at question number 2, right? So the question number 2, they give us the summary statistics. So if you still remember, this summary statistic came from explore button, right? So if you click on analyze, descriptive statistics, explore, and click on statistics only, it will give us this kind of result, right? So now let's look at this one. So it gives us the value of mean, 95% confidence interval. This is the lower bound and this is the upper bound. Median value, variance and standard deviation, minimum, maximum, interquartile range, and skewness, right? So now let's try to answer one of the question. The age in years of the chef in part A were analyzed using SPSS, and figure 1 shows give the summary statistic of their age. Based on the figure 1, answer the following question. So the question is A, how old is the oldest chef? So the oldest chef would be the maximum lah. The maximum value, the oldest chef is 64 years old, right? Years old. And comment on the skewness and explain what it means. It means that, so kita tengok dekat skewness ni is 0.418. This is a positive value. So this we have a positively skewed distribution. So it means that the number of older chef is smaller compared to number of younger chef, right? So we can also say that there are a lot of most of the chef is younger, and there are least chef available in this restaurant lah. So explain the meaning of median age of the chef. So the median is 40. The median is equal to 47.5. So we can say that 50% of the total chef are having age less than 47.5, while another 50% of the chef is having age more than 47.5 years old, right? So that's how we answer the question. Very simple question. So you no need to worry. So I leave it the rest for you to answer by yourself. So we have 10 questions. If you have any question, please be free to text me on WhatsApp or personally. You can also email me to ask the question, right? Okay, I think that's all. Thank you very much. Assalamualaikum.